Hello friends, my name is Bhavesh, and in previous video we discussed about types of DC motors, and in this video we are discuss about the direction of rotation of DC motors. Okay, so start. Let's get start. Okay, so theory is invariant from this circuit that if the armature current were reversed by reversing, the armature leads but leaving the field polarity same, torque would be developed in a counterclockwise direction. Likewise, if the field polarity were reversed in leaving the armature current as shown, torque would be developed in counterclockwise direction. Okay, this is figure. Okay, so however, if both the direction of the armature current and field polarity were reversed, so torque would be developed in a clockwise direction as before. Hence, the direction of rotation of the motor can be reversed by reversing the current through either armature winding or the field coils. If the current through both is reversed, motor will be continue rotate in the same direction as before. Okay, so I am write this. Okay, so it is evident from this figure that if the armature current were reversed by reversing the armature leads, but leaving the field polarity the same, but leaving the field polarity the same, and torque would be developed in a counterclockwise direction. Okay, torque would be developed developed in a counterclockwise direction. Okay, if the field polarity were reversed, if the field polarity were reversed leaving the armature current as shown, torque would be developed in counterclockwise direction. Okay, torque would be developed in counterclockwise direction. However, if both the direction of the armature current, the direction of the armature current and field polarity were reversed, so torque would be developed in clockwise direction as before. Torque would be developed in clockwise direction as before. Okay, hence the direction of rotation of a motor can be reversed by reversing current through either the armature winding or the field coils. So third point is, okay, hence the direction of the direction of rotation of a motor can be reversed by reversing the current, can be reversed by reversing the current through either the armature winding or the field coils. Okay, if the current through both is reversed, the motor will continue to rotate in the same direction as before, will continue to rotate in the same direction as before. Okay, so the direction of rotation of DC motor, so this is figure, this is the rotation, normal rotation, reverse rotation with field connection reverse, and the third is reverse rotation with armature connection reverse. Okay, so this is DC supply and series field and armature rotation. Okay, so the theory is the evident from this figure that if the armature current were reversed by reversing armature leads but leaving the field polarity same, torque would be developed in a counterclockwise direction. If the field polarity were reversed, leaving the armature current as shown, the torque would be developed in counterclockwise direction. Okay. However, if both direction of the armature current and field polarity were reversed, the torque would be developed in clockwise direction as before. Okay, and hence the direction of rotation of motor can be reversed by the current through either the armature winding or the field winding coils. If the current through both is reversed, the motor will be continue to rotate in the same direction as before. Okay. Okay, so these three types of figure, three condition we are drawing this. Okay, and the third is okay. Okay, please see these figures. So this is our first figure. In this illustrate a DC series motor with the direction of rotor assumed to be clockwise. Shows this in this figure show connection to the field winding reverse giving reverse rotation. Okay, and this show alternative method when the armature connect at the brushes and interchanges. Okay, again I'm this is figure. In this figure, DC motor with the direction of rotor rotation assumed to be clockwise, and B shows the connection to the field winding reverse giving the reverse rotation. Okay, reverse giving the reverse rotation. And third is C, the alternative method when the armature connection at brushes and interchange. Okay, and this is okay. So we first complete this. The figure 1. Okay, DC motor with the direction of rotation assume to be clockwise. Okay, and second figure show connection to the field winding to the the connection to the field winding reverse giving reverse giving reverse rotation. And the third is, this is third, and it show the alternative method when the armature connection of connection at the brushes connection at the brushes are interchanged. Okay. Okay, so when we this three figures, in first figure, the DC motor with the direction of rotation assumed to be clockwise, the connection to the field winding reverse going to rotation reverse giving reverse rotation. Okay, and the third is alternative method when the armature connection at the brushes and interchange. Okay, so second is, and the second is, in this figure, 1 2 3 is the method of reversing direction of rotation of the DC shunt motor. This is for a shunt motor, and only one point in this figure, the methods of reversing the direction of rotation of a DC shunt motor. Okay, and the third is, this is the direction of the DC compound motor may be conventionally reversed by reversing connection to the armature, as shown in figure. This is figure. Okay, so this is third and last. The direction of a DC compound motor may be conventionally reversed by reversing the connection to the armature. Okay, so this is normal 3 points. The direction of rotation of a DC compound motor may be conventionally reversed by reversing the connection to the armature Okay, in this figure B, and the reversal of the field connection involve both shunt and series field winding as shown in figure 3. So our point is complete. Okay, so our point is complete. The direction of DC motor is complete. Okay, so thank you very much. Have a nice good day.